Hey, good morning, everybody. How are things going? Hope you had a good 4-day weekend. Um, got some work done, but also got some time to enjoy being outside. It was nice weather. So, a couple of announcements first before we hop into the little lecture, mini lecture for the day. Remember, you have your electric bill is due tonight. If you have questions on that, you can text me. You can go to the discussion board. Um, you can email me, you can Schoology message me, whichever you'd like to do, and we can help you solve any problems you're working on with the electric bill. Um, let's see. The electric bill, just a reminder, the electric bill is worth 30 points. It is going in your test category. So that hopefully will increase the importance of making sure you do it and do it well, because it'll be scored just like a test. There's only really going to be two categories now in this term, as opposed to a test category, a lab category, and a homework category. There's really just test and homework or activity type work stuff. So whether that goes to 80-20% or 70-30, I haven't decided. Probably 70-30, but we'll see. But this is going into that higher test category. Next, I've got like 6 of you that did the decision day video. It was really fun to see where you're all going. But I would really love to see more of you do that. It'd be fun. It's nice to see your faces and anywhere. So please consider doing that. And yeah, let me just hop into what we're going to do today. So I want you to go to page 7 of your notes. That's the first thing that you found on your outline today, is to take the notes down. So this is the schematic, and if you haven't, just pause this and go to Monday, April 27th, I think it is, and copy down page 7 of the notes. But this is what you'll see. This is a clear view of those notes, and this is a combination circuit. So here you can see we have a series portion, meaning there's only one path for the current to flow right through here. But then it gets here and it breaks up into a parallel path, and then it comes back down into the battery. Okay, so this is combination. We have series and parallel all in the same circuit. So just like in the past, the first thing you do is you take and you put in what's known. We have a 2 ohm resistor here, we have a 6 ohm resistor here, and we have a 3 ohm resistor here. Those were given, all from up here. 12 volt battery is given. And then, like the other ones, we start out with the total resistance. Now, a combination circuit is like a hybrid. Hopefully you remember from biology what a hybrid is. It's a combination of two types of things, 2 species or 2 whatever. So we have, we can't just simply go 2 plus 6 plus 3 and add them up like a series resistor or series circuit, because it's not. Nor can we take 1 over 2 plus 1 over 6 plus 1 over 3 and treat it like a parallel circuit. So what you do is series circuits are easiest. So if we can somehow make this into a series circuit, we could just simply add them. So what I'm going to do is I'm going to make this into a series resistor. Okay? And so what I'm going to do is I'm going to take and use that product over the sum rule. I'm going to take, if you remember this one, RT is going to be 6 times 3 over 6 plus 3, product over the sum. So 6 times 3 is 18, 6 plus 3 is 9, so this is equal to a 2. So in other words, right in here, we could replace these 2 resistors with a 2 ohm resistor. Okay? So now when we get our total resistance, we have 2 plus 2 equals 4 ohms. So 2 plus 2 equals our 4 ohms. Okay? So that's how you treat a combination circuit. Reduce the parallel circuit to 1 resistor, whatever its equivalent resistance is, and then add it to whatever you have in series. And you could have another resistor over here in series, then it would be 2 plus whatever this is. Okay, if we had that. All right, so then like before, we're going to go right across our board, our table. We got 12 divided by 4. Remember Ohm's law, V over R. 12 divided by 4 is 3 amps. So I have 3 amps total. Okay? Now I have 6 things left to solve. And there is only one thing that I can fill in without showing any work. Do you know what that one thing is? Of these 6, only one of them really doesn't require any work. It's the current at resistor number 1. This has to be 3 amps. I have 3 amps coming out of my battery. It has to go through that resistor. No option. Okay? So then you would just write series here. But we're not going to do that type of a test question. But so here's the tricky part. The next thing you do, some of you would say, well, in parallel, the voltage is the same. So this gets 12 volts and 12 volts. And that's not correct in a combination circuit. The reason why is you have to figure out how much voltage is required to get through this before you get to this. So we have to find the voltage drop here next. Okay? And how do you find voltage drop? You take I times R, again, Ohm's law, solving for V, which is 3 times 2 equals 6 volts. So right here, I have a 6 volt drop. Okay? Now, I have a 12 volt battery. I just spent or needed or used or dropped 6 volts. So how many volts do I have left? 6 volts. These two get 6 volts, whoops, and you would write parallel. So the total voltage that's left, which 12 minus 6 equals 6 volts, that goes to your parallel part. That doesn't split to 3 and 3. Voltage does not split. The current will split. So let's go back to current. We have 3 amps coming through here. Okay? It's going to split. Will it split 50-50? In other words, 1.5 amps up here and 1.5 amps down here. What do you think? There's 2 branches. Why not just cut it in half? The reason you don't just cut it in half is because the resistance is not the same in each branch. You'll see in a little video clip about this being paths for streams to flow down a mountainside. This one might have not very many rocks in that stream. This one might have some pretty big boulders because there's a lot of resistance in it. So current takes the path of the least resistance. So more current's going to go here, less current's going to go here. How do we find out how much current goes in? We use Ohm's law. We have 6 volts divided by 6 ohms, 1 amp. Over here I have 6 volts divided by 3 ohms, 2 amps. And look quick. Does 1 plus 2 equal 3 amps? Yes. And that was my total. Okay? So that's how you would solve that. One quick thing, you're going to read today in your reading, you're going to read the proper placement of a fuse in a circuit. A fuse has a symbol like this. It's like a little snake symbol. Okay? A fuse or circuit breaker is designed to stop the current flow to a particular part or the entire circuit. Typically, fuses are placed in series so that if this blows, the whole circuit shuts down. If we wanted to just spare this item, like this was a really expensive motor or something in this complex circuit, and we wanted to make sure that that motor did not get damaged with a lightning strike or a sudden surge of current due to a short circuit or something like that. And then we would put the fuse maybe right there. Okay? Another thing you're going to learn about is a short circuit. A short circuit would be if this was, pretend this is like a little alligator clip wire here, and there's a little alligator clip wire to make these circuits, these branches. If this somehow happened to be touching this, that's kind of laid on the table in a lab setting or whatever, then current is going to go and go right from here to here and bypass this resistance. Again, current takes the path of least resistance. and there'd be less resistance in this blue wire than there would be to go through the parallel branches of the circuit. When that happens, again, when resistance goes down, like say if this is our resistance here, if resistance goes down, then the current shoots up. And if current shoots up, that means you have, typically you're going to blow a fuse or a circuit breaker. Okay? So that's just something you're going to read today about fuses and placement of fuses and short circuits, just so you can kind of see what that might look like. Okay? I think that covers it for the day today in terms of content. Work on your electric bill. Do a good job with that. There's some reading, some textbook questions. I think there's a worksheet assigned for today. Good amount of work to do today, but I know you can handle it. So feel free to give me feedback on the discussion board. Do your decision day. Have a good one.